Hello there, Coach Reza. My name is Owen Beatty, student number 101379668, and this is my video submission for assignment 2 in our data science class. So jumping right into it, here are my student credentials and all my import statements. I'll jump right into my logic for part 1, the tennis portion. So the played column, the label, will be set to false if any of the two following conditions are evaluated true. So I have three variables: temperature, rain, and wind speed. Temperature being between the range of 0 and 20, and if the value is less than 10, so below 10 degrees, then that's one strike on being able to play tennis that day. Same thing with more than 5 millimeters of rain and more than 20 kilometers an hour wind speeds. So if any two of those conditions are evaluated to true, then they would not have played tennis that day. So let me just make sure to read that and print out all of the values from the CSV sheet which I've made. Here it is. And now this is just it in Google Colab. So all of the values there, and then I put them back into their specific rows and columns to try and to then have the decision tree read it. And then I have four different variations of the test here. So this is with this first one is with all three good variables. So it's 20 degrees out, it wasn't raining at all, and it was barely windy, so it always evaluates to true. Now this is the complete opposite, where everything is bad. It was a bad day, it was cold, it was stormy, it was rainy, and that always evaluates to false. And now this was me testing out how the decision tree works. We have one bad variable in here, which was the rain, and it understands that the temperature and the wind speed were both in an acceptable range. Even though the rain was a problem, they still played tennis anyway. And then test 4, we have three bad edge cases where it's very just too cold, just too rainy, and just too windy, and it understands that all of those are bad variables, and it is evaluated to false. Now, part 2, the COVID section, I set infected to true. Once again, pretty similar logic, but the temperature was in the range of 97 to 102 because that's generally the safe range of temperature for a human, where 99 is the threshold for if you have a fever. And then I just used simple sneezes and coughs because I wanted to stay away from using Boolean values. I wanted to specifically evaluate to integers for the trees. So if you have more than 5 sneezes a day or more than 15 coughs, then those are 2 more strikes indicating that you are infected. So I will actually pull up the COVID sheet real fast. Here it is. We'll use it again in a second once we get down to the bottom. I will once again read these. Here are all the values, and then set into their specific rows and columns again. And here I set the test, the index to the ones that we want to test at the end, from 50 to 60, which I'll show you once we get there. I ignored the other, what would that be? The other 50% of the data, since you said you only wanted us to use 30%, so this is 10% and this is 50, leaving, so that would be 60 total, so we used about 40% of the data remaining. Or no, actually, I used 30, yeah, because that's 10, 20, 30, 40, yeah, okay. So, yep, we used 30% of the entire sheet to test, or to train, and here's me removing it, and then running the decision tree down here. So once we predict if someone has COVID in this, we see it's evaluating to, going down from the bottom up, true, 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 false, true, 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 false, true, 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 false, true, false, true. So from the bottom up, we have the exact same values because the decision tree had properly predicted which if you had COVID or not based on the values I gave it, and the accuracy in this case is 100%, which in theory or in practice would never be the case because we would have too many other variables and too much ambiguity, and it would be very difficult to achieve that if I had something like five columns instead of three and a ton more like just differences in the data. Of course we would have an accuracy that is much lower. Anyway, that is my video assignment 2, so have a great weekend.